In this unit, we will talk about adding and subtracting fractions. In particular, we will talk about the connection between adding and subtracting whole numbers and fractions, and we will answer the question, why do we find a common denominator when we add or subtract fractions with different denominators? In kindergarten and first grade, students represent numbers with sets of objects, and they represent addition by putting the sets together. In second grade, students relate numbers to links and represent addition by putting links together. Also in second grade, students use their understanding of length to represent numbers as points on the number line. To represent 4 plus 3 on the number line, we go 4 units to the right of 0, and then the sum is the point that is 3 units to the right of that. To represent 4 minus 3 on the number line, we go 4 units to the right of 0, and then the difference is the point that is 3 units to the left of that. In fourth grade, students add and subtract fractions with like denominators, which is exactly analogous to adding and subtracting whole numbers. They start by representing fractions as a sum of unit fractions, mirroring the way they built fractions from unit fractions in third grade. Note that the representation on the number line is identical. What is new in fourth grade is the explicit connection to addition. Students in third grade recognize the equivalence of whole numbers and fractions, which they can use in fourth grade to understand how to write a mixed number as an equivalent fraction. Let's take 1 2/3 as an example. First, they understand that a mixed number is a sum of a whole number and a fraction, so 1 2/3 is 1 plus 2/3. Then they write the whole number as an equivalent fraction with the same denominator as the fraction they already have, so 1 is the same as 3/3. Then they can add all the thirds together. This is how they can explain the equivalence of 1 2/3 and 5/3. The meaning of addition is the same for both fractions and whole numbers, even though algorithms for calculating their sums can be different. In particular, diagrams that represent addition of fractions are the same whether the fractions have the same denominator or different denominators. The sum of 3/4 and 2/3 is represented in the diagram in the same way that we represented 3/4 plus 2/4, but it isn't clear what fraction it represents besides 3/4 plus 2/3. With a little more work, we can figure this out. If we partition the fourths into 3 equal pieces, and then the thirds into 4 equal pieces, we haven't changed the numbers, just the way we named them. Now all the pieces will be the same size, and they represent twelfths. So now we can see that 3/4 plus 2/3 is 17 twelfths. Fifth grade is when students understand and explain why we find a common denominator when we add fractions with different denominators. Let's go through another example. If we want to add 1/2 and 3/5, we can partition the halves into 5 equal pieces to see that 1/2 is the same as 5/10. Then we partition each fifth into 2 equal pieces. And see that 3/5 is the same as 6/10. If we put all the tenths together, we see that we have 11/10. To add fractions with unlike denominators, we rewrite them as equivalent fractions with the same denominator so that the unit fractions are the same size. In general, if we want to add 2 fractions, a over b and c over d, we can partition all the b's into d equal pieces and all the dths into b equal pieces. Now everything is written in terms of the same size pieces, or same kind of unit fraction. And we can express the sum in terms of the unit fraction 1 over b times d. We have a times d of them from the first fraction and b times c of them from the second fraction. That is why we get a common denominator and then add the numerators when we add fractions.